Hey guys, welcome to lesson 7.2. There is a lot to this, so let's go ahead and jump in. The first thing I want us to consider is this function f of x equals 1/2 x, which of course we know is just a line. What we've been talking about is finding area. We're going to do something totally different with these things. So instead of finding area, what I want us to think about is, let's say we take this region, and I want to slim it down here. Let's just go from 0 to 2. Okay, so ignore this part of it. Okay, so I want to take this region and this area and I want to revolve it around the x-axis. Okay, so think of taking this and rotating this around so that you get an actual solid. So what's going to happen is, as you rotate it, you are going to get a 3D object. Okay, and it is going to be a cone. Hopefully you can see that, right? You can see if that's a cone. So now it is super easy for us to use geometry formulas and find the area of that cone, no problem. But if this function were not linear, if it was some sort of a curve, we could still take a curve and rotate it around an axis and create some sort of solid of rotation, we call them, and we would want to find the area of those. And we can do that using calculus. The book has some really great pictures of examples of these. I want you to think like pistons in manufacturing. Some of you who do 3D printing may already have some ideas of things that actually you can generate by rotating. But I want to think about this really simplified form, and then we'll kind of expand it. So if I wanted to find this, and if it wasn't something super easy like just a cone, if it was something more complicated, what I could do is I could slice it up into little discs. Okay, you can't see those, can you? Can you see blue ones? Okay, so imagine taking this and slicing it up into little discs. Think about those little toys you played with as a kid that maybe got smaller and smaller. What we want to do is find the area of all of those discs and add them together. Well, those discs are all circles. I just want to take one of them to look at. Let's just look at this one, for example. Okay, so to find the area of a circle, that's just pi r squared. Well, what's the radius of that circle? The radius of that circle is whatever the function value is there. Okay, it's because the radius of this circle is going to be bigger, and it's determined by this. So we take pi times whatever the function value is, and we square it. And we can do that, and we would find the area of any of these. Now, what we want to do is slice this into infinitely many little discs and add them all up. Okay, so think of slicing this into millions and millions of really thin pancakes, and they're all basically circles. We're going to find all of the areas and add them together. So the way we do that with calculus is we take the integral from whatever our point A to point B is, and move that so it's not in our way. That's what we're going to do. Now, pi is just a constant, so we can pull that on the outside. So to find the area of the solid, it's pi times the integral from a to b of whatever our function is. Now, your book doesn't use f of x. It uses r of x just to represent the radius. Okay, but that function defines the radius of all of those different circles. So it is just the area formula for a circle. Pi r squared, it's just we have an infinite number of circles. Okay, we call this the disk method for finding volume, and it is written in your book exactly like this. If you want to find the volume, it is pi integral from a to b of rx. Sorry, I forgot the dx. We use this when we have a horizontal axis. Okay, so if you have a horizontal axis of rotation, which is what we had up here, we were rotating around that horizontal line. If you've taken this and revolving around a vertical axis of rotation, so if I had asked you to rotate around this, and that would create a kind of a cone shape over here, the formula does not change, except we have to be in terms of y instead of x. So we do r of y squared dy, and that is for a vertical axis of rotation. Okay. So again, this is called the disk method. I'm going to show you a couple examples how we work with this, and then it does have one little more complication called a washer. It's when we put holes in things. It'll be super fun. It'll be great.